Hello, and welcome back to another edition of Algebra 2 Math. Today, we are working on Lesson 8. Again, we're just going to practice a little bit more. First thing on your lined paper is I would like for you to write this down and write down what A, B, C, and P mean. I am going to start putting up the answers. If you have not finished, please pause because I really want you to take a second and do this on your own. Okay, so A is the amplitude. How high? It's the midline up and the midline down. B is the frequency, which is the number of cycles from 0 to 2 pi. C is the midline or the vertical shift. P is the period, which is not found in the equation. It is either found in the graph or given in the word problem. If you need to find the period, you can use the frequency to find it, which is P equals 2 pi over B. Conversely, if you know the period and need to find B, the frequency, you can use that equation also. The P and the B are related. Okay, for the first example, I do not want you to write this all down. What you're going to do when I get to it is you are going to sketch a graph, and it is a sketch, and then you're going to write down the answers to A, B, and C. So in this example, we're talking about tide. It is a very common question for a cosine curve. Oh, oops. That's the wrong tide. This is the actual tide, right? High tide, low tide, the current affects it, something with the moon affects it. But this actually is very relevant to trigonometry and our cosine curve, and you will often see questions about the tide. Let me read this to you carefully, and if you need to pause and read it yourself, please do that. The tides in a particular bay can be modeled with an equation of the form D equals A cosine B of t plus C, where T represents the number of hours since high tide and D represents the depth of the water in the bay. The maximum depth of water is 36 feet. The minimum depth is 22 feet. And high tide happens every 12 hours. Okay, so they're telling us it's a cosine curve. They are not using x and y in the equation. They're using d and t. It's the same thing. T is the x. Time is always the x-axis, right? So they often replace the x with a t. And they're using d for depth or height, okay? Part A says, on the axis, sketch a graph of this scenario for 2 full periods. Label the points on this curve that represent the high and low tide. All right, so I'm going to go back to my problem and look for what is important in there. So it's telling me that my maximum depth is 36 feet. My minimum depth is 22 feet, and high tide happens every 12 hours. So I feel like the max and min is pretty self-explanatory, but I'm not really sure about the 12 hours. Well, let's take a look here. I'm going to start at my high tide. of 36 feet. So I'm just going to say this max is 40. We don't want to say it's 36 because that's a little weird. And so I'm going to put 36 feet about right there, all right? And I'm going to mark that. Okay. And the minimum depth is 22. So this will be 20. So that means 22 is about right there, right? So I think I can mark where the minimum is going to be, but I'm not 100% sure where on this graph. But what I do know is that high tide, which is the same as the maximum depth, happens every 12 hours. So what that is saying is 12 hours later, I will be at my high tide or my maximum depth again. So what I'm going to do is I'm going to mark 12 hours here. And I'm going to mark my max right there again, because at 12 hours, I'm back to high tide. So if I know this is a cosine curve, I know that I'm going to hit my min halfway in between there, right? Well, what's halfway between 0 and 12 hours? 6 hours, right? So I have myself now a nice little cosine curve. However, common mistake, we do that nice little curve, we think that we're good, but the directions said 2 full periods. So that 12 hours, I didn't really explain it in math words. I just said it was from the max to the max, or from high tide to high tide. Well, what does that mean? It's the period. It's one full cycle is 12 hours. But they want us to graph 2 full cycles. So I'm just going to repeat it again. So I'm going to mark my next high tide. It's going to be another 12 hours later. So it's going to be at 24 hours. And it's going to be my max, or my high tide is there. So that tells me my low tide is going to be in between there at 18 hours, about right there. And then I'm going to continue. So I have now graphed 2 full periods. I have 2 cosine curves, okay? Part B says determine the values of A, B, and C in the model. Verify your sketch is correct using a calculator. So I need to find my A, B, and my C. I like to deal with my A, my A and my C first. I don't know my midline. It's not given. My amplitude is from my midline up and my midline down, which I don't have my midline. But I, just like we did in the last lesson, I can figure out what that is. So to find the amplitude, I'm going to do my max minus my min, which is going to give me 14. Now that's the height, not the amplitude. The height's from, max to min or min to max. The amplitude is half of that. So I'm divide that by 2 and I get 7. So my amplitude is 7. Okay. Now I can use that to find my midline or my C or my shift. So I'm going to do my C, or my midline. I'm going to take my max and I'm going to subtract my amplitude. Gives me 29. I'm also then going to take my min and add my amplitude. I should get the same number. Even though you get the same number, you should do them both to make sure you didn't make a mistake anywhere. So my C, or my midline, or my shift is 29. Now if I go in and kind of eyeball where 29 is on the graph and sort of draw a dotted line across, doesn't that look like the midline? Okay. Now the last thing I need to do is figure out my B, or my frequency. Now the B, you cannot always pull from the graph, especially this graph. You can't pull it because we're not labeling our x-axis in pi. So if the frequency is how many cycles from 0 to 2 pi, well, we don't know where 2 pi is. I mean, we could maybe figure it out, but it's easier to do it the other way. But I do know that my period is 12. That's what we talked about, right? So if I know my period is 12, I can use the formula that I used on the first page to figure that out. From here, I'm going to cross multiply, divide by 12. That reduces to 1/6. I'm going to write it as pi over 6, which is the same. So your B is pi over 6. Okay. So now that you have your A, B, and your C, you can plug that all into your equation. And I would also then graph it on your calculator to see if it looks like the graph that we made. D equals 7 cosine pi over 6t plus 29. That is your equation. That's where all the hard work went. Okay. Part C says tanker boats cannot be in the bay when the depth of the water is less or equal to 25 feet. Write an inequality and solve it graphically to determine all points in time on the interval from 0 to 24 when tankers cannot be in the bay. Round all times to the nearest tenth of an hour. Okay, this sounds a lot worse than it is, but what I'm going to do is I'm going to grab the line y equals 25. So the midline was 29. So 25 would be a little bit below here. And this question is saying that tankers can't be in the bay when the water is at that height or lower. So basically from here to here and here to here, it cannot be in the bay. Okay, now the question is, what are those points of intersection? Especially since this is just a sketch. It's not an accurate graph, right? Our answer, when we do get it, we're going to say from here to here and from here to here. That's what they mean by the interval. So how do we get those exact points? We're going to use our calculator. In your y1, you're going to put your equation. In your y2, you're going to put 25. When you graph it, it'll look something like what we've already done. You're going to have to change your window. I would change your window to match exactly what's in our graph. Then you're going to find 4 points of intersection. So you're going to have to do this 4 times. If you struggle with this, please chat me separately and I can show you a video of it. So you're going to hit second. Then you're going to hit trace or the calc button. Then you're going to choose 5 intersect. Once you do that, it's saying first curve. You're going to move your cursor so it is close to the first point of intersection. There's 4, so it doesn't know which one you're talking about. When you hit enter, it's going to jump onto the straight line and say second curve. It should be very close to where you are. Just hit enter again. Then it'll say to guess. Remember, we don't guess. You hit enter again. On the first point, it should say your x value is 4.2 for rounding to the nearest tenth, and your y value should be 25. And then you're going to repeat that 3 more times. Okay, I have marked on the graph the 4 points of intersection. Notice the y values are the same as they should be 25. I have 4.2 to 7.8 hours, right? And then from 6.2 to 19.8 hours, those are all at or below the 25 feet mark. So how would I write that? I would say the time For the first interval, time has to be greater than or equal to 4.2. I wrote that backwards because I want the time to be in between, but it also has to be less than or equal to 7.8, right? So I'm saying that the time is in between 4.2 and 7.8 hours, and you have to address the second one. Again, time is in the middle, and we have 16.2 and 19.8. That is a lot for that page. All right, next question. The height of a yo-yo above the ground can be modeled using the equation h equals 1.75 cosine pi times t plus 2.25, where h represents the height of the yo-yo in feet above the ground, and t represents time in seconds since the yo-yo was first dropped from its maximum height. Determine the max and minimum heights the yo-yo reaches above the ground. Show the calculations. Okay, so this time they've given us the equation, which is nice, so we don't have to write it, but we still have to find the max and the min. Now, could you put this in your calculator and do that? Yes, you can. However, it does say show your calculations. So does anybody remember how we do this? What we're going to do is we're going to take our midline. So our midline is, or C or a midline is 2.25. And then I am going to add my amplitude to get my max. So what's my amplitude? It's 1.75, which gives me 4. Hopefully, if you did this on your calculator, you can confirm for me that it's 4. And then to do my min, I'm going to do my midline and I'm going to subtract my amplitude to see how low it will go. And that gives me 0.5. Okay, so that's what you do for that. Part B says, how much time does it take the yo-yo to return to its maximum height? I guess the question is, what are they really asking here? It is a vocab word, but they're not straight out using the vocab word, which normally in a real life situation, that's not going to happen. Well, we're starting at the max, right? If you go back to the equation, it's saying that t represents the time in seconds since the yo-yo was first dropped from its maximum height. So they are telling you, and realistically it makes sense from a yo-yo, right? You start with the yo-yo wound up and then you drop it, right? So they're saying how much time does it take to go back to the maximum height? What is that vocab word that they're talking about? If you guessed period, that is correct. It's really one full cycle is from max to max, so that is period. So how do I find my period? Well, they don't tell me in the equation, do they? They don't say how long it takes from max to max. But what I do have is my B, right? Remember the period and the B, the period, the frequency are interchangeable. So I'm going to write down the equation that I need for that. And I know for a fact that my B is pi. It is given to me in the equation. So I'm going to plug that in. So 2 pi over pi. Well, that's pretty straightforward with solving it. I'm going to cancel out my pi's. So the period is 2. And if you're not sure how we're measuring it, it's 2 seconds. And doesn't that really make sense that it would take 2 seconds to toss your yo-yo and have it come back up based on those heights? The possible hours of daylight in a given day is a function of the day of the year. In Kingston, the minimum hours of daylight, which is the winter solstice, which is denoted here. You're going to have the least amount of daylight, is 9 hours. And the maximum, which is the summer solstice, which is coming up, which is like my favorite ever, is 15 hours of daylight. If the number of hours of daylight can be used modeling a sinusoidal equation, what is the amplitude? Oh, that's another amplitude question. I don't have an equation, I don't have a midline, but again, I do have my max and my min. So my max is 15 hours, my min is 9 hours. If I subtract the two, 15 minus 9, that gives me 6. That is not the amplitude, remember, that is the height. If I want my amplitude, I'm going to do 6, I need to divide that in half, 3. So my amplitude is 3. Okay, so this question here is your homework. Read it carefully. You do not have to copy everything down. You do need to show me a sketch of your graph. Doesn't have to be perfect, it is just a sketch. You also need to answer A, B, and C. Now, can you use your calculator to do a sketch? Yes, but your calculator is not going to label everything the way that it needs to be labeled. So what is different about this one than the previous graph we did in the notes is they don't give you the period. Okay, so I'm just going to give you a little hint here. This is the frequency. You know your frequency, so you know what B is equal to. B is equal to 4 pi over 5. So you are going to use that to find your period. Then you will be able to label your x-axis and draw one complete period. All right, that is the end. I hope you had fun. I can't wait to see you again. Please join me for homework help if you need it. I hope to see you all there. Cheerio!